Welcome students to this evaluation of Cauchy's integral formula. Consider this problem. Evaluate integral over the contour C, z minus 2 by z into z minus 1 into dz, where C is a circle mod z equal to 3 using Cauchy's integral formula. So here mod z equal to 3 refers a circle with center 0, 0 and radius 3. Okay. So here we have to find out first the singular points by equating the denominator of the function z into z minus 1 equal to 0. You are going to get z equal to 0 and z equal to 1. Now since the circle is having the center 0, 0 and radius is 3, definitely the point z equal to 0, z equal to 0 is a origin and the point z equal to 1 is the point 1 comma 0 is a point 1 comma 0 lies inside the circle mod z equal to 3. Hence, we are having the singular points both lies inside the circle C. In previous case, we have observed that if one of the point lying inside C, then how to evaluate the integration, we have understood it. But here, if one point lies inside C, you have to keep the other point as some function, and you have to have the point which lies inside C alone in the denominator. Whereas here, both points lies inside the contour C. Therefore, we have to separate it with the help of partial fraction method. Then only we can apply Cauchy's integral formula. Why? Cauchy's integral formula says that f of a equal to 1 by 2 pi I integral over the contour C f of z into dz by z minus a. Here the point z equal to a lies inside C. Because of this, we are separating the 2 points which are lying inside C by making use of partial fraction method. Now, we have to get what is the value of A and B. How to get it? So, by taking the LCM, you will get A into Z minus 1 plus B into Z. Put Z equal to 1, you will get B equal to 1. By putting Z equal to 0, you will get minus A equal to 1. So, A equal to minus 1. Therefore, we are getting A equal to minus 1 and B equal to 1. Substitute it here. So, minus 1 by Z plus 1 by Z minus 1. Now, we are going to apply Cauchy's integral formula. So, integral over the contour C, f of z into dz by z minus a into dz equal to 2 pi a into f of a by Cauchy's integral formula. Okay. So here, what is f of z? F of z we are going to consider as z minus 2. Integral over c. By making use of partial fraction method, you can have minus 1 by z plus 1 by z minus 1 into z minus 2 into dz. So here we can break this integration like integral over the contour C, okay, f of z by z minus 1 into dz minus integral over the contour C f of z by z into dz. The z can also be written as z minus 0. So because of this only, we are having, this is 2 pi I into, okay, 2 pi I into, this is, you are having 1, f of 1. At the place of a, you are having 1, so f of 1 minus 2 pi I into, okay, in the place of z naught, you are having what? Or a, you are having, okay, 0. So in this place, you are having 1, a equal to 1, a equal to 1, and here a equal to 0. So you have to put a equal to 0 here. Now putting z equal to 1, putting z equal to 1, what is the answer you are going to get? Here it should be minus 1. Okay, because f of z equal to, okay, f of z equal to z minus 2. So f of 1 is going to be minus 1 and f of 0 is going to be minus 2. So put here minus 2. Okay. Therefore, you are going to have minus 2 pi I, okay, minus 2 pi I plus 4 pi I. So the answer is plus 2 pi I, plus 2 pi I. Hope you understood, I think. Here, you are having 2 points lies inside the contour C. So first you are separating it by partial fraction method, and then you have to apply Cauchy's integral formula. Now we'll go on to the next problem. Evaluate integral over the contour C cos pi z square divided by integral z minus 1 into z minus 2 into dz, where mod z equal to 3. Here mod z equal to 3 means what? It is a circle with center 0, 0 and radius is 3. Okay. Now first here you are going to make use of Cauchy's integral formula. By making use of Cauchy's integral formula, we are going to evaluate it. Why here we are having Cauchy's Rusty theorem is the same problem you can solve it with the help of Cauchy's Rusty theorem. You will get the answer same, but the methodology is different. So first step, you have to get the singular points. For getting the singular points, you have to equate the denominator of the function as 0. That gives you z equal to 1 and z equal to 2. Since the circle is having center 0, 0 and radius 3, the point z equal to 1, what is the meaning of point z equal to 1? Z equal to 1 is the point referring 1, 0 and z equal to 2 is the point referring 2, 0. How? Because we know that z equal to x plus iy. By equating the real and imaginary point, you are getting like this. So let us take it as 1, 0 here, that is z equal to 1, and z equal to 2 somewhere here you can take z equal to 2. So both points lies inside C. As like previous problem, you have to separate it with the help of partial fraction method. So by separating with the help of partial fraction method, you can find out what is the value of A and B, like A into Z minus 2 plus B into Z minus 1. By taking Z equal to 1, you are having minus A equal to 1. This gives you A equal to minus 1 and put z equal to 2, you will have, okay, b equal to 1. So you are having the value of a as minus 1 and b as equal to 1. Substitute here, we are getting minus 1 by z plus z minus 1 plus 1 by z minus 2. Now you are going to make use of Cauchy's integral formula. So the numerator we are having cos pi z square, that we are going to take it as f of z. F of z equal to cos pi z square. Okay. So here minus sign is there. Cos pi z square divided by z minus 1 into dz plus integral over the contour c cos pi z square divided by z minus 2 into dz. So what is a here? A equal to 1 here. Here a equal to 2. Therefore, according to the Cauchy's integral formula, you are going to have integral over the contour c f of z into dz divided by z minus a equal to 2 pi I into f of a. So, you are going to put, okay, in this place 2 pi I into f of a is 1. Already minus sign is here, we are putting minus sign, plus 2 pi I into a equal to 2, that's why f of 2. Now put z equal to 1, so you will get f of 1 equal to cos, okay, pi. The value of cos pi is minus 1, and then you have to put f of z equal to 2, that gives you cos 4 pi. Okay, we know that cos n pi equal to minus 1 to the power n. So you are going to have minus 1 to the power 4. This gives you 1. Hence, okay, 2 pi I minus 2 pi I into f of 1 value is minus 1 plus 2 pi I into, okay, f of 2 value is plus 1. So we are having 4 pi I. Hope you all got clear. Now we are going to see one more problem. Take down this problem, evaluate the same previous problem. I am going to consider in this manner: integral over the contour c cos pi z square plus, let us take it as sin pi z square divided by, okay, z minus 1 the whole square into z minus 2 into dz, where c is mod z equal to 3. You all know what is mod z equal to 3 is. So mod z equal to 3 means it is talking about the circle x square plus y square equal to 3 square. Okay. Now see here, what is f of z? F of z equal to, let us take cos pi z square plus sin pi z square. Okay. How to get the singular points? Singular points can be found out by equating the denominator to 0. So this gives you z equal to 1 and z equal to 2. Now we have to analyze that the point, okay, z equal to 1 lies inside C. What is C here? It is having the circle with center 0, 0. Let us take this point as 0, 0. this point is 0, 0, okay, radius is 3. So definitely the point z equal to 1, let us take this as z equal to 1, and this point is z equal to 2. So definitely both point lies inside C. Here the point z equal to 2 also lies inside the contour C. Next, if both points lies inside C, what we have to do? We have to separate it by making use of partial fraction method. So let us write a divided by z minus 1 plus b divided by z minus 1 the whole square plus c divided by z minus 2. By cross multiplying and taking the LCM, you are going to get z minus 1 the whole square, because already, sorry, um, 1 z minus 1 is here, so it is enough to multiply one more z minus 1 into z minus 2 is not present here, so put z minus 2 plus b into already z minus 1 power 2 is there, so it is enough to multiply it by z minus 2 plus c times, okay, z minus 1 the whole square is the highest power, so that we are going to multiply it here. Now take put z equal to 1. If I am putting z equal to 1, the first term is going to be 1 equal to, first term is 0, second term you will get b into minus 1, third term is also 0, so this gives you b equal to, okay, minus 1. Then when you are putting z equal to 2, okay, 1 equal to, first term is 0, second term is also 0, third term we are going to get 1. So c into 1, that gives you c equal to 1. Then take z equal to, or if I am comparing the z square term, okay, z square term on both sides, the left hand side has no z square term. From the right hand side you will have a into z square, so a alone you have to write, plus here no z square term, here you will have z square term, z square into c, so plus c. Therefore this gives you a equal to minus c. What is c here? A equal to, you will get minus 1. Okay, therefore 1 divided by z minus 1 the whole square into z minus 2 equal to, okay, a is minus 1 divided by z minus 1 plus b is also minus 1 divided by z minus 1 the whole square, okay, plus c is 1 by z minus 2. Okay, so here now next integral over the contour c cos pi z square plus sine pi z square divided by z minus 1 the whole square into z minus 2 into dz is going to be, here I am going to consider integral over the contour c minus f of z divided by z minus 1 into dz minus integral over the contour C f of z divided by z minus 1 the whole square into dz plus integral over the contour C f of z by z minus 2 into dz. What is f of z here? F of z we have considered it as we are taking f of z equal to cos pi z square plus sin pi z square. So according to Cauchy's integral formula, what you are going to get? This step is going to be, this is equal to, okay, minus 2 pi a into, what is in the place of a? We are having 1 minus 2 pi a into, here you have to be careful. This is power 2. So this I can write it as z minus 1 the whole power 1 plus 1. What is the Cauchy's integral formula? According to Cauchy's integral formula, okay, integral over the contour C f of z by z minus a to the power n plus 1 into dz is equal to 2 pi I by n factorial into fn of a. So here it is going to be n equal to 1. So 1 factorial into f dash of a. Then plus, okay, 2 pi I into, here the power is 1 only. This power is 1 only. So you are going to have 2 pi I into f of a. What is a here? 2. We know what is f of z. So from this we can able to find what is f of 1. What is f of 1? Cos pi plus sin pi. Cos pi is minus 1, sin pi is 0, so minus 1. Then f of 2 is what? F of 2 is cos 4 pi plus sin 4 pi. We know that cos 4 pi is plus 1, sin 4 pi is 0, so it is equal to 1. Then what is f dash of z? F dash of z is 2z. Okay, differentiation of cos is minus sin pi z square. Then plus 2z into differentiation of sin is cos pi z square. So next you have to put what is f dash of 1. Here what is um, in the place of a, we are going to put 1 here. So this is 1. Okay, f dash of 1 is going to be minus 2 times of sin pi. Sin pi is 0, then cos pi is minus 1. So here you are going to have minus 2, which is equal to minus 2. Understood? Put z equal to 1. When you are putting z equal to 1, you are getting minus 2 into sin pi is 0 plus 2 into cos pi is minus 1. So you are having minus 2. Substitute it here. This gives you minus 2 pi I into f of 1 is minus 1 minus 2 pi I divided by 1 factorial is 1 into f dash of 1 is minus 2 plus 2 pi I into f of 2 is 1. Okay. So you are having plus 2 pi I plus 2 pi I 4 pi I. Here also plus 4 pi I, that gives you 8 pi I. Hence, the integration of this, I can call this as I. So integration value is 8 pi I. Hope you all understood. Here in this problem, I have given it as integral over the contour C cos pi z square plus sin pi z square divided by z minus 1 the whole square into z minus 2 into dz, where the circle is mod z equal to 3. So f of z equal to cos pi z square plus sin pi z square. Find out the singular points by equating the denominator of the function to 0 gives you z equal to 1 and z equal to 2, and these 2 points lies inside C. Since 2 points are lying inside C, we have to separate it, then only we can apply Cauchy's integral formula. So here we are separating that by making use of partial fraction method and find out the values of A, B, C. Then here if you are seeing that by according to the Cauchy's integral formula, integral over C f of z into dz by z minus a power n plus 1 is 2 pi I by n factorial into fn of a. So here you are having 2. That 2 I can write it as 1 plus 1. So n equal to 1. Apply n equal to 1 case. You are having minus 2 pi I by 1 factorial into f dash of 1. Other terms are normal way you are going to write. Then find what is f dash of z. At that point z equal to 1, you are having the answer is minus 2. Substitute it here and you will get the answer is the integration value is 8 pi I. Hope you all understood. We'll see in the next session.